All right, guys, so we're starting a new chapter today. We're skipping chapter 16 for right now. Today we're going to start radical expressions. We're going to simplify them. For the most part, when you're talking about variables and square roots, it's fairly straightforward. So hopefully pay attention today. There's not a whole lot of sections in this chapter, and then we can get a good test in. I want to start off by looking at the square root of 4. We all know the square root of 4 equals 2. But why it equals 2 is because this is really the square root of 2 times 2. That's the same thing as 4. And when you have a pair of things and you're taking the square root, you can pull that out. So we're going to use that to look at the next few that have variables. So the same principle applies for the square root of a squared. That's really the square root of a times a. So I have a pair, so the answer to the square root of a squared is just a. Let's look at a to the third, though. If I have a to the third, that's the square root of a times a times a. Now we're taking the square root, so I want pairs. Well, I've got one pair here, so I know I can take an a out. But the other a doesn't have a pair, so it's stuck inside the square root. So your answer is a square roots of a. So try a square roots of 4 if you pause it for just a second. I'm going to go ahead and write it out. That's a times a times a times a. So I actually have 2 pairs of a. So what I'm going to do is say I can take out one a, and I can take out another a after multiplication. So the answer to square root of a to the fourth is a squared. A to the fifth, you might be seeing kind of a trend happen here. I have a times a times a times a times a. Well, I can group up some pairs here. I've got one a that I can take out from one, and then another, but one a is going to be stuck inside. So my answer is a squared square roots of a. So try a to the sixth, the square root of a to the sixth, and the square root of a to the seventh. You may not have to write anything out. I think on the square root of a to the sixth, we can kind of see, well, the square root of a squared was a, the square root of a to the fourth was a squared, so the square root of a to the sixth would be a to the third. We'd have 6 a's inside the square root. We would have 3 pairs of a's, so we took out a to the third. A to the seventh. Well, I know if I look at the pattern, a to the fifth was a squared, a to the third gave me an a, so I'm thinking a to the seventh is going to be an a to the third. But there would be another a without a pair, so there's going to be an a stuck inside. So you can kind of see that there's a pattern when you're doing variables with exponents and square roots. Let's scoot down the page just a little bit. And it says, what's the pattern? You may put this in other words than I do, but it looks like we're dividing the exponent by 2, and if we have a remaining exponent, we leave it in the square root. So I'm going to say divide the exponent, whoops, maybe I should put an E on there, exponent by 2 if there is a remainder, keep 1 inside. And that's not the best explanation there, but I think you could probably come up with one on your own. Sometimes when we do geometry, we'll say, you write your own little thing for the pattern, so you might write one there. But you just divide the exponent by 2, like a to the sixth. We had a to the third left. But if we did a to the seventh, well, we'd get the 3, but we'd have 1 left over, so we left it inside the square roots. So let's use that and answer some of these questions. Some will be, these all should be fairly quick and easy. A to the 24th. Well, if I divide my 24 by 2, I get 12, so I get a, so the 12th is my answer. A square root of a to the 40. Well, I divide 40 by 2, I get 20, so I bring out a to the 20. A to the 120. Well, 120 divided by 2 is 60, so I get a to the 60. But now we have an odd exponent on the inside, and we divide it by 2, we're going to have something left over. Well, 31 divided by 2 would give us 15.5, so I have a to the 15th, but that 0.5 means I leave 1 inside my square root. So the same thing on the other two. 47 divided by 2 is 23.5, so I have a to the 23rd, but that 0.5 means I leave 1a inside the square root. And then, of course, square root of a to the 10th, we could get real quick, is a to the 5th. So, guys, these are pretty quick and easy. We're going to add in some numbers in a second. You may have to get some prime factors. But other than that, as far as the variables go, they're pretty quick and easy. Let's go to the back page. Now notice this says simplify, okay? You cannot put these in your calculators. You may let the calculator help you with some number stuff, but as far as the variables go, you're going to have to know how to do that on your own. Now, one way to do these is to write it out. The square root of 144y squared is really the square root of 144 times the square root of y squared. Now, you may not have to write that out, but sometimes it helps. Now, I'm going to check that number in my calculator probably and see what is the square root of 144. If it's a whole number, that's going to make my life a lot easier. If it's a decimal, we're going to have to do something like you'll see in number 3. But the square root of 144 happens to be 12. And we know the square root of y squared, we divide the 2 by 2, we get 1, would be times y. So the answer is just 12y. So even if it's a number guy, you kind of treat it the same. You're going to pull it out and multiply it by whatever else you pull out as well. I have 81, a to the 4th, b to the 6th, c to the 10th, and I want the square root of that. Now again, I'm going to write this separately. I have the square root of 81, the square root of a to the 4th, the square root of b to the 6th, and the square root of c to the 10th. Now, again, I want to check the number. We should know what the square root of 81 is. It's 9 times the square root of a to the 4th would be a squared. Now we're using b and c. And guys, that should not bother you. They work just the same. The square root of b to the 6th is b to the 3rd. And the square root of c to the 10th is c to the 5th. Now, you could write that without those multiplication signs, but, you know, we may eventually have numbers out there, so you need to be careful. I got 9a squared, b cubed, c to the 5th. So we threw in those numbers, we threw in multiple variables, but, guys, the process is just the same. Now, number 3 is going to change it up a bit. I have the square root of 24x to the 5th. That's the square root of 24 times the square root of x to the 5th. Now, we can do the square root of x to the 5th pretty easy. We divide 5 by 2, or we get 2. So I'd have x squared, but we'd have 2.5, so I leave 1 inside. So as far as that one goes, it's not too bad. But the number is not a good square. It's not a perfect square. If we put that in our calculator, we're going to get a decimal. So we need to break it down. I'm going to take 24, and I'm going to break it down into its prime factors. So I'm always going to try to start dividing it by numbers like 2, 3, 5, 7. I know 24 is divisible by 3, so I'm going to say 2. Well, 24 divided by 2 gives me 12. Well, 2 is a prime, so I'm going to keep it there. 12, I can also divide that by 2, and I get 6. Well, 2 is prime again, but 6 isn't because I can do 2 and 3. Now, I have 2 times 2 times 2 times 3. That's 24. So I'm going to rewrite my square root of 24 that way. 2 times 2 times 2 times 3. Now, I want to pick out pairs just like we did with the variables. I've only got one pair. I got a pair of 2's. So that means I can take a 2 out of my square root, but the 2 times 3 stuck inside, so that's 6. And I'm going to multiply that by what I had up here. When I multiply it, I just multiply the outside terms. 2 times x squared is 2x squared. And then I have the square root of 6 times the square root of x is really the square root of 6x. And that's your answer. So those numbers can complicate it a little bit. If you'll just start dividing, think of 2, 3, and 5. That generally will get you where you need to go. But break it down until you have only prime factors left. Let's look at number 4. The square root of 75, x squared y cubed. Now, some of you may not have to write this out like I've been, and that's totally fine. That's the square root of 75 times the square root of x squared times the square root of y cubed. Now, I'm going to go ahead and do the x squared and y cubed because those are pretty easy. I know the square root of x squared is x. And I know the square root of y cubed. Well, I divide that by 3 by 2, I get 1.5. So I take out 1y, leave 1 inside. Now, we just need to break apart our 75 into its prime factors. Well, anything that ends in 5 and 0, guys, divide it by 5. 75 divided by 5 gives me 15. Well, I can divide 15 by 5 also, and that leaves me a 3. Well, 5, 5, and 3 are all prime numbers. Let's change the square root of 75 to that. That's 3 times 5 times 5. Now, I can see if I have any pairs. I do have a pair of 5, so I'm going to take that out. But the 3 is left inside, and then I need to multiply that by my other two terms. 5 times x times y is 5xy. Then I'm going to have the square root 3 times y is 3y. So there's your answer. Now, guys, I can see the number giving you some trouble, but you have calculators. You know how to divide. You should be able to break it down to its prime factors. Once you do that, it's pretty simple. Let's go down and look at the last few. Number 5, this is our biggest number of the day we're going to have to break down. I have got the square root of 162, a, b to the 6th, c to the 5th. So I'm going to break that apart. Square root of 162 times the square root of a times the square root of b to the 6th times the square root of c to the 5th. Again, I'm going to go ahead and hit my variables first. Square root of a I can't do anything with. There are no pairs. But the square root of b to the 6th is b to the 3rd. The square root of c to the 5th I can take out a c squared and leave a c inside. Now let's take our number and let's break it down. I've got 162, and guys, it ends in a 2. The best thing to do is divide it by 2. 162 divided by 2 leaves me 81. Now, you may be able to see 81 is actually 9 times 9. I'm going to go ahead and break that down here. We don't always have to use primes, but if it's not a prime, we need to keep breaking it down. Well, 9 is 3 times 3, and I have 2 of them. So I'm going to change my square root of 162 to the square root of 2 times 3 times 3 times 3 times 3. Now I can count up my pairs. I've got one pair of 3's here and another pair of 3's there, and the 2 is going to be stuck inside. So what I have is one 3 pulled out and another one, but I left the square root of 2. I still have the square root of a, the b cubed, and the c squared square roots of c. Now I can do my multiplication. Well, 3 times 3 is 9. 9 times b cubed is b cubed, and then c squared. Inside the square root, I have 2 times a times c. So there's your answer. It's kind of a big one, but still, guys, that's not too bad if you'll just take it step by step. Let's look at the next one. This one's a little weird because it's got a number outside the square root. 3 times the square root of 121, m to the 4th, n to the 5th, p to the 7th. I'm going to go ahead and split that one up again. Again, you don't have to do this every time. The 3's outside, the square root of 121, the square root of m to the 4th, square root of n to the 5th, square root of p to the 7th. Well, guys, you should always try out numbers just in case, because the square root of 121, that is a perfect square, and you get 11. So I'm going to say 3 times 11 times the square root of m to the 4th, we should know by now, is m squared. The square root of n to the 5th, I'm going to be able to pull out an n squared, but I'm going to have 1 that can't pull out, or that can't come out. Then I'm going to have the square root of p to the 7th is p cubed times the square root of p. Now we can do our multiplication and we'll be good to go. Well, 3 times 11 is 33. Then I have m squared, n squared, p cubed, and inside the square root is n times p. So there's your answer. All right, guys, we got one more. Number 7. It's got that 5 hanging around just like number 6 had a 3, so I'm going to go ahead and write that out here. I've got the square root of 72, the square root of x to the 5th, and the square root of y to the 4th. So I'm going to go ahead and break down 72. It's our last little trial today. It ends in a 2, so I'm going to take out a 2. I'm left with 36. It's still even, so I can go ahead and take out another 2. It leaves me with 18. I can take out another 2. That leaves me with 9. And we've already seen 9 is 3 and 3. So I can replace my square root of 72 with 2 times 2 times 2 times 3 times 3. And then I know that x to the 5th, the square root of that, is x squared with an x left inside. And I know the square root of y to the 4th is y squared. Now I just need to pull out my pairs. I've got a pair of 2's and a pair of 3's, and I can do my multiplication. So that's a negative 5 times I can take out a 2 times I can take out a 3, and I have the square root of 2 left. I know I have x squared, square roots of x, and I know I have y squared left as well. So now I just have to combine all my terms, and I'm good. Well, negative 5 times 2 is negative 10. Negative 10 times 3 is negative 30. Then I have my x squared, y squared outside my square root. Inside, I have the square root of 2 and the square root of x, so the square root of 2x. So, guys, the hardest part of all this is getting the square root of these numbers that aren't perfect squares. Do your division. It'll get easier the more you do. If you're just going to give up and not try, it won't ever get better. So give these a shot. If you need help, just let me know. Good luck.